Good morning, my dears. This is Dr. Hussain Basha Pathan. I am working as assistant professor in the Department of CSC, PACE ITS, Velluru. So now I am introducing the course Automata Theory and Compiler Design. In that particularly, I have to choose the context-free grammar. Now onwards, we are discussing about the context-free grammar. Let us discuss about the context-free grammar. Before going to discussion of the context-free grammar, here I am telling that what is a grammar, and next one is the regular grammar. These are the two concepts we have to discuss before discussion of the context-free grammar. Here I am telling that what is a grammar, and next one is a regular grammar. So here I am telling that grammar. In generally, grammar is having that formal rules for designing of or else generating of the a correct sentence. So we are using the grammar for the formal rules. So here let us take the grammar can be considered as a G. So in that we have to take that ATPS. So in generally this VTPS is called as a four tuple. Four tuples. So here each and everyone having its own identity. So here we consider as a finite set of non-terminals. Non-terminals, or else we call it as a variables. Okay. So here I am telling that V is a finite set of non-terminals or else variable we call it. So these variables are represented with uppercase letter. So here V is represented as a finite set of non-terminals, and as well as these are represented with the uppercase letters. It is also as a state of finite automata. These are all state of finite automata. Then next, here again T is represented as a finite set of terminals. Or else symbols. These are represented with lower case letters. Okay. So here P represents as a production rule. So S stands for start symbol. So here I am taking one example for this one, this grammar. Along with example we are discussing that. So here I am taking the one finite automata state, that is Q0 is a one state and Q1 is a one state. So here the one is a transition of the Q0 and one is a transition of the Q0, and again Q1 is having that 0 and 1 transition inputs. So here this can be converted into the grammar part. So here I am taking that. So here I am taking Q0 and Q1 is a V. It means variables or else state of finite automata, and those are represented with the Q1 is means that uppercase letters. Okay. So again 0, 1 are a symbols. It is represented with the T, and next one is that some of the production rules are there for Q0 0, Q0 1 like this. So here I am taking that start symbol Q0. So the given finite automata can be represented in the grammar part. Q0 and Q1 is considered as a variables, and 0 and 1 is a symbols, and q naught to 0, q naught to 1 is represented production rules, and q naught is a start symbol. So here I am taking that another one example for our considerations. Okay, so this is called as a production rule. So how to write the production rules we are discussing here. Production rules, how to write the production rules. So here in the production rules there are two parts are there. First one is the left hand side and second one is the right hand side is there. Single non terminal symbol. Okay, from right hand side we have to take that epsilon, or else strings, or else terminals, or else non terminals. So every time the production rules are having that left hand side and right hand side. Two parts are there. From left hand side we have to take single non-terminal symbols, and right hand side we are taking sometimes epsilon, strings, terminals and non-terminals. Based on this one here I am writing that S is a start symbol and along with the that one is a non-terminal. So here the right hand side terminal A is having the lowercase letter and that is called as a terminal. B is a non-terminal uppercase letter. Here C is also uppercase letter non-terminal. So here B is a right hand side non-terminal. Here right hand side we are taking as a epsilon. So here left hand side we are taking as a C, that is non-terminal, that is left hand side. So here right hand side I am taking that terminal, that is lowercase letter, like this. So here the grammar can be represented with the help of four tuples. Those are V, T, P, S. V means set of non-terminals and variables. T means set of terminals and symbols. P is the production rules, and S stands for start symbol. So here I am telling the each and every one. After that we are focusing on the concentration on the regular grammar. Regular grammar. So here also whatever the grammar follows the four tuples, so those four tuples same as follows in the regular grammar. So in the regular grammar VTPS. So here V stands for the variables and non-terminals, T stands for the terminals and symbols, P production rules, and S stands for the start symbol. So here there is only one difference between the grammar and regular grammar, that is in the production rule only. So here we have to just find out what is the difference between the regular grammar production rule and grammar production rule. So here again we are considered as two sides. One is the left hand side and second one is that right hand side. So here the left hand side we have taken that single non-terminal terminal symbol. Same as it is the right hand side we are taking as a epsilon and as well as a terminal and a non-terminal. And here also I am taking that terminal followed by here there is only one difference between the regular grammar and general grammar. So here epsilon terminals and non-terminals are there, but here the terminal followed by the non-terminal, either another case non-terminal followed by the terminal case. Based on these production rules, we have to see the one example. So here it follows the left linear grammar, right linear grammar. Based on the production rules, the terminal follows by the non-terminal and non-terminal follows by the terminals. Based on that one, we have to follow the two rules, that is left linear grammar and right linear grammar. So we are discussing one example, along with one example, that is, so here a left linear grammar and right linear grammar is there. So here I am writing that production rules. So here I am writing the production rules. Those are starts with S and here, and again it transfer the with the help of A, it reaches the B state, and again the B is having that the self transition A, and B is having that another transition. So B to C. So here A is having that A transition and B is having that B transition to the final state. So in this way, so we are considered as a S A B is a, here A is a terminal and B is a non-terminal. It means that the non-terminal follows by the terminal. So that's why we call it as a right linear grammar. So here again that B is also follows the AB. So again this one is also having that right linear grammar, and this one is a A. So again here B is follows the BC. So C is a right linear grammar. So here A is having that A terminal and B is having that B terminal. So here we have to see only the right terminal of the regular grammar. So same like that right linear for converted into the left linear, along with one example we have to see. Conversion of left linear grammar to right linear grammar, along with one example. So here I am taking the one context free grammar. It means that here I am taking the finite automata. Based on this finite automata, I have to write down the uh, production rules. Production rule. So these are the production rules. Those are having that right linear grammar. This total follows the right linear grammar. Why? Because S is the start symbol, A is the terminal, and C is the non-terminal. Here the left-hand side single non-terminal, and here the terminal, and here the non-terminal. So those are all having that right-hand side. That's why we call it as a right linear grammar. This can be converted into the left linear grammar. There is four rules and regulations are there. First of all, construct finite automata. Already we done that one. The next one is interchange the initial state to the final state, and change the arc directions, change the arc directions, and write the right linear grammar, and fourth one, write the left linear grammar. So these are the four rules are there for converting the right linear to left linear, or else left linear to the right linear. So here first of all construct the one finite automata based on the production rules. So here I am taking the first finite automata. After that I have to write down the production rules. So here first of all first point is over, construction of the finite automata. Based on this one we have to interchange the initial state to the final state and final state to the initial state, and as well as the we can change the directions. So we can change the directions. After that write the right linear, and after that write the left linear. So here I am roughing this one. If you are observing, I have to change the first whatever the initial state is there in the previous diagram. Yes, so here I am writing the D is the initial state. So in the final last state is D. So here the final state is S. So here I am interchanging the initial state to the final state, or final state to the initial state, and as well as change the arcs. So if you are observing that I am changing the directions also, from S to C is there, but here C to D is there. So here C to B is there, but B to C is there. Like that only I have to change the directions. Right now I have to write down that uh, production rules. So this is a left linear grammar. This one is a right linear grammar. If you are observing the directions and as well as the interchanging of the final state to the first state and first state to the final state, based on these rules, I have to write down the third point, right linear grammar and as well as the left linear grammar. So in this way, there may be conversion of the left linear grammar to the right linear grammar and right linear grammar to the left linear grammar. So this is the way to representation. After that, we have to discuss about the context free grammar. So I was already told the previous context free grammar before going to discussion grammars and regular grammar. So now we are discussing about the context free grammar. Whatever the tuples are there in the grammar, same as easily we have to take in here also. VT, PS. So same directions here I am taking, same four tuples we are taking here. Okay. So here V is having that non-terminals, T is having the terminals, P is the production rules, and S is the start symbol. So here there is only one change in the production rule, that is here also we are taking as a single non-terminal symbol or else variable. So right hand side we are taking as a epsilon string terminal and non-terminal. Okay. So based on these production rules, we have to generate the context-free grammar. We have to see one example for this one. Here I am taking one example. Construct context-free grammar which accept all the strings for at least for at least 2 A's over the alphabet alphabet sigma is equal to A comma B. So this is a question, that is construct context free grammar which accept all the strings for at least 2A's over the alphabets sigma is equal to A comma B. So here I am writing that string, like a string is like A plus B. Here A is there, A plus B. A is there, A plus B. So this is our string. In between the two A's are there, at least two A's are there in between the string. So here I am taking A plus B multiplication, A plus B multiplication, A plus B multiplication. So this can be right into the context free grammar along with the production rules. Say here I am taking the production rules like this. So this is a production rule. Left hand side starts with the non-terminal and as well as the right hand side. So non-terminal, terminal, non-terminal, terminal, non-terminal. So here again the T stands for that non-terminal and non-terminal. So or else I can write that non-terminal and non-terminal, here epsilon. So based on these production rules, based on these production rules, I have to solve the problem as given. So here I am taking that again T A B. Sorry. TAT. So here again, so here I am substituting the values of T. In place of T, I have to write down BTA, BTA, BT. So here, in place of the T, again here I am substituting the epsilon value, epsilon A, B epsilon A, B epsilon. So here, removing of epsilon, so here I am writing BA, BA, B. So this is the string equation of the whatever the given the problem. That is, in between that we have to place the two A's. Here A is there, here E is there. So like this only we have to solve the problems in the context free grammar. So thank you.